Okay, so as promised, we're going to prove this problem here. I've copied the two statements from before. I'm going to prove just the first one, and I'll leave proving the second one to you as an exercise. So how can we prove this statement here? Well, as we've mentioned before, if there's any redundant junk in the precondition, we should immediately get rid of it by precondition equivalence. Same goes for the postcondition to make our lives easier. Now, clearly true and x greater than y is the same as x greater than y, right? True and anything is that anything unchanged. So this thing is logically equivalent to x is strictly greater than y. So we can do precondition equivalence backwards to get this slightly simpler quadruple. Okay, so if I can prove this, then certainly I can prove this by precondition equivalence. How are we going to prove this? Well, you sit there and you think a bit, well, I don't know, looks like we're going to have to do assignment either forward or backwards, right? So I'm going to try doing assignment backwards, I mean. So m is greater than or equal to 0. M takes on the value of x take y. So if I replace, let's have a look at my rule sheet. I'm replacing the x's to get e's, so I'm going backwards. So I'm replacing the m with x take y. So I'm going to get x take y is greater than or equal to 0. Aha, this looks really useful, right? Because I can rearrange this so it's going to look like this. I can use precondition equivalence. Well, x take y greater than or equal to 0 means x is greater than or equal to y. That's an if and only if. So I can do precondition equivalence. X greater than or equal to y. Same code as before. And the same postcondition. Well, this is almost the case. But thankfully, x strictly greater than y is more restrictive than x greater than or equal to y. If you assume x is greater than y, it's certainly the case that x is greater than or equal to y. As a reminder, what does this mean? X greater than or equal to y is just a shorthand for x is strictly greater than y, or x is equal to y. So if x is greater than or equal to y, certainly x is greater than or equal to, if x is greater than y, I beg your pardon, then certainly x is greater than y or anything, including x is equal to y. So this is a true statement here. So then I can strengthen my precondition by replacing the weaker precondition with a stronger precondition. So now I can add in my rules. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This was assignment. This was logic. This was precondition equivalence by lines 1 and 2. This was logic. This was precondition strengthening by lines 3 and 4. If you wanted to, you could probably skip straight from 1 to 5 by just asserting that x minus y greater than 0 is implied by x greater than y. And just jump straight from here down to there. That's fine. If you do it in multiple steps, it's easy for you. Doesn't really matter. Anyway, so we use these two lines to get to here by precondition strengthening. True and x strictly greater than y is the same as x strictly greater than y by logic. Therefore, I can put 5 and 6 together to get 7 by precondition equivalence. Lines 5 and 6. Line 8's got no justification. I invite you to prove line 8 as an exercise. So again, it's going to be like a separate proof. Well, it's going to be almost the same proof as this, just with like negatives floating around. Negations, I beg your pardon. Negations floating around. And so once you've proven 7 and 8, you can put them together to get 9 by the sequencing rule. Sequencing 7 and 8. Okay? So that's how you use the conditional rule.